Hello fellow problem solvers. So they're going to be doing another number theory problem, which I suggest you try out for a minimum of 20 minutes, ideally 45, not more than 2 hours. If you'd like to go along with us, give it a go for the next 15 minutes. It's a good number theory problem to practice your number theory skills at a medium to beginner level. Okay, so let's look at this problem. We have finding positive integers a and b such that these two are relatively prime, y, and that a plus b divides this. Okay, 4ab plus 1. So when I see 2a plus 1 and 2b plus 1 are relatively prime, I immediately think like this is hinting at if I multiply them, something is happening. And if I multiply them, there's really not much. I get 4ab, I get minus 1 plus. I get plus 2b minus 2a. Right, so it's not very cool. I can't connect this to this. And I think to myself, how can I actually connect these two things, right? Maybe 2a plus 1, 2a plus 1 times something. So maybe times 2b. That's going to give me 4ab, but I don't have the other thing. Maybe times 2b plus 2a. Like this is also divisible by this is going to give me 4a plus 4ab. And actually 4a squared plus 2a plus 2b. If I subtract these two, I'll get 4a squared plus 2a plus 2b minus 1. Right, am I able to factor this in any way, shape, or form? This is divisible by a plus b. I'm able to get rid of this. Okay, and now I have a plus b divides 4a squared minus 1. And it makes sense, like if you were to add them up, like it's good to double check that you haven't made any algebraic mistakes. And how I checked it right now is, okay, if I add these two up, I get a plus b divides 4a times a plus b, so we're good. So okay, I see I have 4a squared minus 1, which is equal to 2a minus 1 times 2a plus 1. Okay, and I also have that a plus b divides in a similar way, because this is symmetric with respect to a and b, while this condition might not be, divides 2b minus 1 times 2b plus 1. Like I can get the same, like just multiplying everything by, I think here, multiplying a plus b by 4b, right? And then subtracting, I can get the same thing. Okay, so now there's these two facts that we have. And these are relatively prime. How do we use that fact? Maybe a plus b is relatively prime to one of these two. We don't know. Let's see what happens if, say, a plus b and 2b minus 1 share a common factor. Say it's b. Then we have a plus b is divisible by this. 2b minus 1 is divisible by this. And 2a plus 2b is divisible by this. Subtract, and you get 2a plus 1 is divisible by this, right? Because I've subtracted this, and then I have p divides 2a plus 1 and 2b minus 1. That's a contradiction because these two are relatively prime. And here I invite you to pause for another 5 to 10 minutes and try to pose the problem further. Because here's the next step. What this implies, there's no prime that divides a plus b and 2b minus 1. So from here, we can infer that a plus b divides 2b plus 1. Similarly, from here, we can say if p divides a plus b and p divides 2a plus 1, then we have p divides a plus b, b divides 2a plus 1, this divides 2a plus 2b, subtract, and then you have p divides 2b minus 1. So again, a contradiction. So we also have that a plus b needs to divide 2a minus 1. And now are both of these simultaneously possible, like for some a and b? But can you see that they are kind of constrained here? And this is why I want you to pause for another 5-10 minutes and see if you can get rid of this constraint in some way, shape, or form. And the thing is, okay, let's see what happens. We can't do any of this. Prime factorize it, like looking at primes, dividing these two. They probably have the same, they probably can share primes. Because if I add them up, yeah. Actually, if they share prime divisor, then they share prime divisor with 2 times a plus b. Is there anything we can deduce from there? I'm not sure. The reason I'm pretty cool just like doing case by case here is because it's not super difficult. What would I do here? There are 2 cases. Either a is greater than or equal to b, or a is less than b. If a is greater than or equal to b, then this thing is difficult to have, right? So in this case, let's do a case by case analysis. So in this case, if a is greater than or equal to b, then from a plus b divides 2b plus 1, we have that this means there exists a positive integer k, because we're in the positive integers, such that kab is 2b plus 1. And now this is going to be less than 3b. I think that's one way of me putting it, less than 3b. Or maybe I'll make it as less than, so 2b is going to be less than or equal to a plus b plus 1, which now gives me k minus 1 times a plus b is less than or equal to 1. Given this number is greater than or equal to 2k minus 1, this implies that k must be equal to 1. And in other words, we have a plus b is equal to 2b plus 1. In other words, a is equal to b plus 1. And now we must check that this actually satisfies both of these claims, like first that these two are relatively prime. And if a is equal to 2b plus 1, then we have 2 times b plus 1 plus 1, and 2b minus 1. This is 2b plus 3. If these share a common factor, then that common factor is divisible by the difference, which is 4. However, both of these are odd, so they're relatively prime. We're good there. And then just double check here. What do we get? We get 2b plus 1, that's a plus b, is going to be, needs to divide 4b times b plus 1 plus 1. And this is just another way of writing 2b plus 1 squared. Like if you write it out, you'll get 2b, this is 2b plus 1 squared. So this is one solution. A is equal to b plus 1, i.e. the solution, any integer x, actually x plus 1 and x. And if we have the other case, I invite you to pause for 3 minutes and finish that case yourself, because we have this. So we have a, if a is less than b, we want to use this thing, and then we're going to have k times a plus b for some other k different from the other case is going to equal 2a minus 1. This is less than a plus b minus 1, which is less than a plus b. And then we have k is less than 1. In other words, k needs to be 0. I mean, actually, that's what implies. K needs to be 0, and that implies 2a minus 1 is 0, which is a contradiction because then a is not a positive integer. So it seems that only the solutions, the pairs of the form x plus 1 and x, where x is any positive integer, solve this problem, or the pairs satisfy the problem conditions. This finishes up our problem, and you can see like trying to sort of use this fact, like that's in the back of your mind, and you're seeing how can I play around with this for a b plus 1? Can I get it to a plus 1 or b minus 1? And when you do, when you get it to, where was that? That was for this a plus b divides 4a squared minus 1. You see you didn't really get it directly, but then you see, okay, let me look at maybe the prime factors. And that's always a good thing. Like if you have some a divides b times c, if you prove that a and b are relatively prime, you just get a divides c, which is much stronger, right? Because this is much bigger. Then you can do some estimates on how big is c with respect to a. Like you're sort of having you're having this side of the divisibility be of a lesser degree, which is better because then you can actually perhaps check their sizes and check how big can they be. So this finishes up our problem, and as always, thanks for problem solving.